Here's an example for an exponential decay function where the base is in between 0 and 1. In fact, anytime we have a base between 0 and 1 in this format, a times b to the x power, we know we're going to have an exponential decay or a decreasing function. Here's this example, 50 times 0.8 raised to the x power. Note the base here is in between 0 and 1, and what we expect for the outputs as the inputs increase by 1 is that the outputs will decrease by a factor of 0.8. Let's look at this table here, which we can verify in our calculators, which you should do. Plug this into y1 and then use your table feature to find and verify these numbers. But look what's happening here. If we plug in 0 here for the input, we get 0.8 to the 0 power, which is 1, and then we get this as an output. So we call this, remember, our initial value of the function. As we increase it by 1 to 1, then we get 0.8 to the first power, or 0.8 times 50, which is really just 80% of 50, and that's 40. As you increase again by 1 here, this is actually 80% of this, and so on. So these guys are decreasing by a factor of 0.8. It's important that you see, in terms of percentage decrease, if you were to take the difference between these as 10, and then 10 divided by 50 is actually 20%. So in your calculators you can do that, take the difference 10 divided by 50, and that's a 20% decrease. And so it's important that you see that this 0.8 has an effect of a 20% decrease as the inputs increase by 1. Remember, so this means that this next value will decrease to a value that is 80% of this, but in between here there's a 20% decrease. It's important that you see that.